Everything would be different. It'd be anarchy. It'd be terrible. I love anarchy. I live for anarchist movements. No, I'm just kidding. Because you know what? Order is important. Nice segue, huh? That's what we're going to do. We're going to talk about permutations where order is important. In other words, what we're talking about is arranging things in specific order so that if I have three things and I arrange them one way and then rearrange them another way, they are different. Okay? A permutation is a set of elements and it's an ordering of the elements. For instance, there are 6 permutations of the letters A, B, and C, namely ABC, ACB, BAC, BCA, CAB, and CBA. Those are 6 different unique orderings. Okay? So that's what we're going to do when we talk about permutations. And this right here is the key word, ordering. Okay? That is the key word. Anytime you have a set, I'm going back. And you want to take everything in the set and arrange it in unique orders, we're going to use n factorial. So there are 3 elements in that first set, 3 factorial, 6. Okay? So given a set of 6 students currently attending Math 110. How many different ways can the students be arranged? We kind of discussed this a little bit when we were talking about the billionaires parking their golf carts. It's the same concept. So there are 6 students. Order is important. Therefore, 6 factorial is the number of different arrangements. And then 6 factorial, anybody know? Okay. And don't forget, you got that key on your calculator. Or your iPad if you're using that. Okay? Now, there are going to be times where I don't want to select every single element in the set. Sometimes I may only want to select a certain number of elements. For example, there are 6 of you. Let's say I only want to pick 3 of you and arrange you in different orders. How many different ways can I do that? Well, that's what a permutation is. Okay? If NPR, little n, big P, little r, where r is always less than or equal to n, that means that this number here on the right must be no bigger than that number. Okay? Is the number of permutations of n elements r at a time, then the formula is given by so. NPR equals n factorial over n minus r factorial. There are a number of different ways to write the symbol. You may see it like this at some point, and you may see it like this. Okay? They all mean the same thing. Now And what that means is we're going to take n items, arranged r ways. That's not really accurate, but it works. So, for example, let's say that we want to arrange the 6 students into a 3-person committee consisting of 3 unique offices. Well, that's basically 6p3, which means I'm looking at 6 factorial over 6 minus 3 factorial, which means I'm looking at 6 factorial over 3 factorial. And I can do 6 times 5 times 4 times 3 factorial all over 3 factorial. I know that the 3 factorials will divide out, and I am going to be left with 120. So 6p3 equals 120. Your calculator will have a permutation key, and you're going to use that instead of using this big old formula, because the formula itself is very easy to make mistakes with. Okay, I thought I had my calculator. There it is. So, everybody needs to find the permutation key on their calculator. If you have the calculator that I told you to get, which none of you do, I don't think, it's the multiplication key. You do 6, shift, multiply, 3, hit equals, and you get 120. On yours, you're going to have to hit the PRB key. So hit 6. No, clear. Hit 6, hit PRB. I think it's PRB, right? Yeah, right there. Okay, and no, get out of there. PRB. What are you doing?
I had it and you touched it and you messed up, see?
Oh, it's my fault, huh?
Yeah.
All right, hit equals. All right, hit equals. Now hit 3 and hit equals again. And there you go. What kind of calculator you got running? Oh, okay. Where's your NCR symbol? Oh, okay. So you're supposed to use the NPR, so you'll have to use shift. Do you have an NPR key on there? Probably not. Maybe. Oil? Matter of fact, you don't. Time to get a better calculator. It does, but not anything that's going to work for you. There's got to be a way to. There's got to be other calculators out there that you can download. Did you find yours? It's in the math, I think. Do you have an NPR key on this thing?
I have a graphic calculator.
You okay? Okay.
It's just getting on my nerves.
I can understand that. Why don't you go flush it out?
There's nothing in there. It still
Well, it's still. Go to the water fountain and stick your eyeball. Why?
Do you know how many people put their mouth on
That's why you let it run before you actually stick your face in it. Oh, so you don't drink from it?
it? Try not to.
You try not to. Okay. So, okay. Let's see how it is. All right. Nothing in life is sanitary.
Yeah, I was wondering if I'm working in a hospital, maybe you would look at the water fountain and say, oh, that is sanitary.
Oh, yes, very much so. Did you know more people die in hospitals because of bacterial infections? No, you do. My father went in for rotator cuff surgery and came out with a nasty bug that almost cost him his shoulder. It took him almost 6 months to get everything cleaned out and fixed up. And he never did, actually, because they had to undo everything that they did in order to get the bacterial infection out of there. So he still has a gimp arm. Actually, it's not that bad, but okay. Find the number of permutations of 5 things taken 2 at a time. So when we do that, that's simply going to be this, 5p2, which if you want to use the formula is 5 factorial over 5 minus 2 factorial, i.e. 5 factorial over 3 factorial, which will be equal to 20. But of course, you can just use the key on your calculator if you have one. No. Hold on a second. Okay. So 9 things taken 3 at a time. That's going to be 9p3. So we need to go ahead and calculate, which is 9 factorial over 9 minus 3 factorial, which is 9 factorial over 6 factorial. And just using that calculator, you're going to get 504. So this one right here, part C, where it says 3p1, there is only one way to choose 3 items, or choose 1 item from 3. Okay? Huh? It's got everything. Yeah. All right. Jesse's geek. Life is good. Anytime you got something that says a number, P1, it's always going to be that number. Okay, for example, if we look at this, we got 6p1, that's going to be equal to 6. What would AP1 be? Hey, there you go. See how cool that is? All right, so let's look at part D, which is 7p3. Go ahead and calculate using your calculators. 210. And then we got 12p2. Okay. Now comes actual application. A collection of 3 paintings by one artist and 2 by another is to be displayed. And how many ways can the paintings be shown? A, in a row. B, if the works are to be alternated. And C, if one painting by each artist is displayed. Well, this is a permutation, but on this first one, they don't give us any restrictions. So it's just going to be 5 factorial. Because if I try to display the paintings on the wall, I have 5 places to hang the paintings in a row. And I can choose from one of 5 paintings for the first spot. But once I've chosen one of them, I've only got 4 left. And then it drops to 3, then it drops to 2, and then it drops to 1, i.e. 5 factorial. And that is going to be equal to 120 ways to hang those 5 paintings in different order. Notice that I'm not asking you what the 120 ways are. I don't care. Okay? I don't care. If the works of the artists are to be alternated, well, for this one, I have 3 paintings, and then I have 2 paintings. The only way to do that is, number 1, I have to go back and understand that I've only got 5 slots, right? And if I'm going to alternate them, I'm going to choose the first artist, and I'm going to pick one of his 3 paintings to go there. Then I'm going to put one of the 2 paintings by the second artist right there. Now I'm going to go back to the first artist, but how many paintings do I actually have to choose from? I only have 2 to choose from, right? So then I go back to the second artist. And now I realize, hey, I only have 1 painting to choose from for that artist. And then, finally, I put the remaining painting by the first artist down, and I'm going to multiply these together. And I'm going to get 12. There are only 12 different ways that I could hang those paintings in this order. Notice that being specific in how I'm doing it really reduces the number of ways that you can hang it. And this becomes important in our study of probability. Now, what about if one painting is displayed by, or I should say, if one painting by each artist is displayed? It means I'm only going to hang 2 paintings, right? I'm going to pick one of the 3 from the first artist. Then I'm going to pick one of the 2 from the second artist. Multiply that together and get 6 ways. Okay. Does that make sense to you guys? Good. Now we're going to talk about something else. We're going to talk about combinations. The number of combinations of n elements taken r at a time where r is less than or equal to n is given by NCR equals n factorial over n minus r factorial times r factorial. Combinations, order does not matter. Order is unimportant. Okay. So checkpoint 8 says use the following to evaluate NCR. Well, I can do that, or I can use my calculator and use the NCR key. But let's look at the first one, part A. Well, this right here, 6C2, is going to be equal to 6 factorial over 6 minus 2 factorial times 2 factorial. In other words, I've got 6 factorial over 4 factorial 2 factorial. Okay? Now, what is 4 factorial times 2 factorial? That's 8 factorial, right? Jesse, don't always lemming off the cliff with me. No, it's not. Okay? I was testing you to see if you guys were awake.
I was just writing down.
It is not 8 factorial. You can't do that. Okay? No, it's fine. I just want you to understand that that's not what it is. Okay? You're better off just going ahead and using your calculator and just typing in 6C2 in this case. So 6 shift divide 2 equals 15. Now, Marlena, for yours, you're going to have to use your right arrow key to go from NPR to NCR once you go into the probability screen. Do you know what I mean?
You can't combine factorials.
No, you have to multiply them out first. Then you can multiply them.
Was that the question?
That was the question, yeah. Okay. Okay. So, 8C4 is 70. And I like this one, 7C0. That's always, there's only one way that you can't choose anything. Right? So anytime you do either a permutation or a combination where you're not choosing anything, there's only one way to do it. 7P0 and NC0 will both be equal to 1. You okay?
I'm sorry, I forgot I had a pay-per-view, and I had to run right there and put it real quick.
Okay. By the way, did you win?
I don't know yet.
You don't know. When do you find out?
Thursday.
Thursday? That's not right. They knew exactly who won.
I know, I'm done. I need to be like, can you just tell me about
What time Thursday?
12?
Wow, so we won't even know until next week, right?
Really?
You need to send an email to everybody.
I will.
Okay, or posting a message in Blackboard to everybody. Yeah. And if you didn't win, you know, our condolences.
Spring Fest on Thursday
What's Springfest?
at an event that we have, and we sell food and stuff, and whatever.
How long have you guys been doing this?
It's here.
Yeah, where have I been?
I don't know.
'Cause I've been here
And
since
it's out in front of
04.
the Student Center at like 12. Hang on, you don't have to buy it if you want.
You mean they don't give you food? What's the point? I don't want to go buy food. I want you to give me food. Where? What speaker?
Is it that Arthur that's supposed to be? No, his name isn't Arthur.
It's an author.
He's the writer.
Author. Say it with me, Jesse. Author. Not Arthur. Hey, he's an Arthur. No, I'm an author. Okay, sorry.
But the Spring Fest is in front of the Student Center at 12 o'clock, and we're selling pizza for $1.
A whole pizza?
No, like a piece of pizza.
So just a slice?
Yeah.
For $1?
Yeah, well, you know what? This is Spring Fest. We're trying to save money.
I can go to Cece's and just get the buffet and eat like 22 pizzas for...
Actually, I can get 16s for free.
Wow, okay.
It's in the crater.
Yeah, there's one on the Beltline. Over there by Hobby Lobby.
Buffet of pizza. I know what it is. I know there's one around here.
Oh, yeah. Oh, yeah. Personally, I think they should open one closer to this campus because I think they would clean up. Because I could just see you guys just all, you know, working bee filing into that place after class, just mowing. It's like what, Subway?
Yeah, who wants to go to But then again, I do.
I like Subway myself, but but you get tired of. I didn't say they weren't. I was just okay. This right here is in the notes, and this walks you through the whole process for doing a permutation or a combination or a factorial on this calculator. Okay. There's also, here's another one that you can use. This right here is a web page. However, I don't think it works on an iPad. Let's check that out. What now? Web 2.0.
I can't quit chewing on them. I'm so nervous.
Shot, yeah, no, it's not going to work. You get that. That's not what it's supposed to do. Do you have Puffin on there?
Yep.
Okay, let's try Puffin, see if it works in Puffin.
Did your kids make those bracelets?
Yeah, unfortunately, I got to wear them.
I love those bracelets.
My girls are just all, you get their little rainbow looms and they're going nuts. I mean, they can get quite complicated. You know, I mean,
Is it
the rubber band bracelets.
I used to make those when I was little, and I'd sell them.
Okay. 2.0. Whoops. Cont.com.
Does it work?
Yep.
I like Puffin.
Yeah.
There's also another one you can use. It's like called Photon.
Yeah, it's not as good.
That's the one my teacher gave me whenever I was in.
Yeah, Photon is hit or miss on my math lab. Puffin works. 99% of the time on my math lab. I have rarely had problems with it. Photon, there's a couple others that are just not all that great. Are you okay there?
I'm fine. I have OCD going on.
No doubt. Okay.
I don't know what's been wrong with me the past day or two.
Too much sugar, maybe? I don't know.
But I'm just ready to find out if I want or not.
Yeah.
And I think that has a big deal of it.
All right.
Talk about nonstop.
Checkpoint number 9. 5 orchids from a collection of 20 are to be selected for a flower show. In how many ways can this be done? In how many different ways can the group of 5 be selected if 2 particular orchids must be included? In how many ways can at least 1 and at most 5 orchids be selected? Hint, use a calculator. Well, that's interesting. All right. So, say what? Which one? The one that I just gave you? Yeah, it is. Hold on a second. I digress.
But on my word study in psychology, we have to do the entomological, whatever, something.
I can't say it because you got me off. The etymology of the words. Okay.
The etymology definition, the dictionary definition, and then our own definition. Well, there was Facebook on it, and so I was like, well, because you just pull out random words on your butt, pretty much. And so I just was looking on there under the S and stuff on the etymology one, and there was Facebook, and I was like, okay, we'll do this, and you know, I got all this down. So when it gets to my personal thing, I put down this social media network that causes nothing but drama, and I underlined it and underlined it and underlined it.
Yeah, but Facebook is so yesterday too. I mean, you know.
Well, I know this, but still.
You know.
And then,
Okay.
We're on Instagram and Twitter though, yeah.
Huh? Yeah. It's where they all.
They put not telling for the smiley face.
Okay, 5 I told you what it meant. 5 orchids from a collection of 20 are to be selected for a flower show. In how many ways can this be done? This does not say anything about specific order, so this is a combination. I'm going to take 20 and I'm going to choose them 5 at a time. Type it into the calculator or whatever app I'm using and get 15,504. That's how many different ways, or that's how many ways I can arrange 5 orchids drawn from a group of 20. Now, what about part B? In how many different ways can the group of 5, which means that I'm looking at 5 blanks here, be selected if 2 particular orchids must be included? Well, that means that I'm going to have a specific orchid right there, and I'm going to have a specific orchid right there. How many orchids do I have left to choose from?
No. Wait,
18.
18.
Now I can choose from 18 different orchids here, then 17, then 16. And I will multiply these together. Actually, it's 1 times 1 times 18C3, which is 816. Because if I look at this, I've got 18 that I'm choosing 3 at a time, right? Because I've sliced out 2 effectively, right? So I've dropped my pool from 20 to 18, and now I'm only choosing 3. So I'm not actually doing a multiplication per se, okay? Because 18 factorial would be 18 times 17 times 16 times 15 times 14 times. Okay? And we're not actually multiplying these, so we'll just do that. Now, in how many ways can at least one and at most 5 orchids be selected? That's why they say use a calculator. Because really, what is it that I'm looking at? I'm looking at choosing 1 orchid, or 2 orchids, or 3 orchids, or 4 orchids, or 5 orchids. Which means that I'm looking at 20C1 plus 20C2 plus 20C3 plus 20C4 plus 20C5. And you would type all that into the calculator. And you would get 21,699. Okay? Which brings us to the review. That's it. Does it get more complicated than that? Yes, it does. And that would be, let's see. Yeah. Let's look at this. Oops. Where did that come from? Hey, cool. I didn't know I had this much stuff here. Well, let's go ahead and do some of these, shall we? What's the matter with you?
I don't know.
You're just stressing. You got too much stress on you, honey.
I know.
Okay.
What's going on? I know.
Come on.
What?
Get mellow. Okay. No, you're doing it wrong. There you go. There you go. You got to stop stressing about the election. You either won or you didn't. Okay? There's nothing you can do. On Thursday, a big event will happen for you. There you go. Okay?
Please tell me that was recorded.
It was. A mailman has special delivery mail for 7 customers. In how many ways can he arrange his schedule to deliver to all 7?
Oh, this is permutation.
I don't know. Is order important?
Well, yes, because this is in how many ways. Can you, and that goes back to the ABC, ACP, right?
Mm-hmm.
How you arrange all that.
Does it say in the problem that order is important? Does it say in how many ways can he deliver such that the order is important? No.
So it's going to tell us that it's important.
It will, in one way, shape, or form. So is this a combination, or is this just a straight factorial? Because, yeah, it's a straight factorial. Why? Because he can deliver to any one of the 7 customers. Then he's only got 6 customers left. Then 5, then 4, then 3, then 2, then 1. Technically, you could call it a permutation. Order really isn't all that important, though. If you talk to somebody who is in the delivery service, there are certain ways that they must deliver in order to minimize fuel costs and maximize, or I should say, and minimize time also. Not in this particular problem, it doesn't. Because it doesn't say it matters. But what's 7 factorial? Okay. What about if he can only deliver to 4 of the 7?
This is the
You think it's a permutation? Right. That means it's 7 something 4, right? You guess? You don't know?
Well,
Is it a permutation or is it a combination?
it sounds like it's
Does it matter which 4 he delivers to? Does it matter which order he delivers them? No, so it's a combination 7C4. Okay. And what is 7C4? 35. Okay. All right, let's call it a day, and we'll pick this up on Thursday. And we still won't know what's going on.